Howdy folks, my name is Eric, and this video is a reply to my 2025 Q2 demos thread on discourse.eom.dev. So if you're on YouTube, there will be a link in the description that will bring you here, where there will be a lot of supplementary materials and code examples. If you're committed to staying on YouTube, that's cool too. Please like and subscribe. Okay, so today we're going to talk about self-hosting an email server, and this is actually a fairly complex thing to be doing. I would probably hope that you are comfortable hosting a website first with SSL encryption or TLS encryption. You'll find that hosting an email server is that plus a few extra things if you want the full experience of being able to send emails over the internet, which is most likely what you're trying to do. You can get less involved setups where you are sending only locally within your network, or you can receive emails from the outside world but not send them. I'll tell you where those steps end for each of those configurations, but to get the full thing, there are a lot of steps. And as we can see here, so I'm using Docker Mailserver to host my emails. There are a few others out there. MailCow also provides a rather comprehensive solution. Both Docker Mailserver and MailCow, though, are comprehensive in the sense that they contain a lot of other packages. We can see here, again, mine's Docker Mailserver. In the anatomy of a mail server, there are a number of different components. We have the mail user agent, which is the client program, the mail transfer agent, which is sending and receiving emails from one mailbox to another, and the mail delivery agent, which is placing them in specific mailboxes. So there are a lot of different parts to a quote-unquote mail server, and those parts are provided by a variety of different software applications. Postfix as a mail transfer agent and Dovecot as a mail delivery agent are generally the most common, and those are the ones that Docker Mailserver is using. I think MailCow also uses those same ones, and the difference between Docker Mailserver and MailCow is primarily these bunch of additional extra programs for security and other stuff. Also, I think Docker Mailserver is going to be all in one, whereas MailCow is a lot of different components. So I'm going to be talking about Docker Mailserver here, and I will show you my configuration for Docker Mailserver, but this video actually will apply to both Docker Mailserver and MailCow, or if you are going all in and hosting your own Postfix and Dovecot independently, good for you. That's going to be fun. But a lot of what I'm going to be talking about in this video is going to apply to any configuration that you have. There's a lot of things around a mail server that you need in order to get things working. So let's first talk about my specific configuration. So this configuration file is available to you. The link to it, it's on gitt.eom.dev. There will be a link to the specific file in the discourse thread, and how useful it is to you depends probably on your setup. If you're using Docker Mailserver and you're using Kubernetes, you can probably deploy exactly this file. If you're not using Kubernetes, you will probably be able to use this file to inform the Docker Compose file that you end up creating, or if you just run a raw command, it will inform that as well. So let me show you the components here of what is being deployed into my Kubernetes cluster, and it will show you what is needed for Docker Mailserver as a whole. So Docker Mailserver is quite simple in that it is all contained in one Docker container. So if you can run a Docker container, you can run all of the things that are Docker Mailserver. A few things that I needed around it, just a Kubernetes thing as a namespace, we don't need to worry about that. A certificate. This is important if you want to be able to at least receive emails. You will also need this to send emails over the internet, but if you want to receive emails from an @gmail.com or an @yahoo.com, I don't trust @yahoo.coms, but anyway, not really. Anyway, so If you want to receive from those addresses, you will at least need to set up some SSL. And SSL is just a good thing to set up no matter what. So I would just recommend setting this up. It's really only necessary if you want to have that, external layer, but it's good to have no matter what. You don't want people on the network snooping on emails either. So set up SSL. In this case, I'm using a third-party certificate authority, Let's Encrypt. You can use self-signed certificates. They're a bit less secure. Again, if you're only doing things on your local network, that's probably sufficient. If you are trying to do things outside the network, again, gmail.com, things like that, those will not accept self-signed certificates, so you will need a trusted authority such as Let's Encrypt, which is what I'm using here. And again, this is specific for Kubernetes because I'm using the Kubernetes certificate manager to manage this certificate. And it's quite nice because it does a lot of things for me automatically, such as this duration here, how long it takes for the certificate to expire. Since I'm doing this in Kubernetes with Cert Manager, I don't need to worry about this. The Cert Manager just handles it. Once these 90 days expires, it's just going to renew the cert in the background and I don't have to do anything. If you don't have Kubernetes set up though, you can still achieve this. CertBot will do exactly the same thing. It's just a more manual process, and there are a variety of ways to use it that will depend on your specific needs. So you'll have to look at the documentation for that. I have pre-configured my network to use this, and I'll show you where that happens later. Beyond that SSL certificate, I also needed a few persistent volume claims. That's, again, a Kubernetes thing. It's just a persistent place to store data. When you're working with Docker containers or any other kind of container, they are ephemeral, and if you store data on the container, it does not persist once that container disappears, and containers disappearing happens often, so you will lose data a lot if you don't store it elsewhere off of the container. That's achieved with these persistent volume claims in Kubernetes, and I think it's just called a volume in Docker. So same basic principle. I have one here for the configuration. That's a bit misleading because it's not totally the configuration. I'll show you what this is used for really in a bit. I just call it config, and they call it config, so it's weird. But I'll show you exactly what it's for in a moment. And this one is for the actual mail. I wanted users' mail to be stored in a permanent place. That's kind of the whole point. So yeah, a persistent volume claim for the actual mail as well. And that one has quite a bit of storage on my end. This is the actual deployment. If you are running this in just Docker, this is probably the most relevant part. This is the part from which you will derive your command. And actually, a lot of this isn't relevant whether you're using just Docker or if you're using Kubernetes. I've been experimenting with this. So like the security context, they recommended adding this in their documentation. I have not seen at least the effect that I was looking for. I'm sure it's done something, but what that has been, I don't know. Interesting. But anyway, we have our volume mounts down here. This is specifically where those go. So the config, this one goes to temp/Docker Mailserver. I'll talk about what's happening in there later. The SSL certs that I have requested, I have placed them manually in this etc Let's Encrypt folder, and I have to specify later down that that is a manual path or a non-default path. And then the mail one goes to var mail, and that's a traditional place for mail to be stored on a Linux server. Which, by the way, you don't actually need anything special for mail on a Linux server. I think it's pretty much just built in. So anyway, I digress. We need to open a few ports, and this is just opening ports on the container. In my case, again, it's Kubernetes. I don't really want to get into the networking in Kubernetes. And if you're running just Docker, there are different ways that you can network Docker containers, and I'm not going to get into that. Point being, the container is listening on ports 25 for SMTP traffic, which is just your base sending and receiving emails. It listens on 465 and 587 for SMTP with TLS. These are not... So if you read up on it, these are the ones you're supposed to use. They all recommend using this, but then when you actually start sending emails, you'll find that everything is still using port 25, and I think they're doing like a start TLS thing. Again, I digress. But we go on. Ports 993 and 995. So these three are for SMTP. It's just raw SMTP. This is SMTP with TLS, and I think this one's like SMTP with like optional TLS. It's called like start TLS. I might have those mixed up a little bit, but it's neither here nor there. Those are for the sending and receiving of the actual emails from one server to another. But for actual clients to log in and read their emails, you need two different protocols called IMAP and POP3. And the ports for those, at least when you are using, again, an SSL connection, is 993 and 995. When you are using an IMAP and POP3, if you're using it over the internet, you absolutely want SSL. You kind of absolutely want SSL when you're doing things over the internet no matter what. So the SSL is being used both for SMTP. You know, on the port 25, I think they eventually will end up using TLS. It's just they start off with non-TLS, and these, it's all just TLS at some point. I don't know the specifics. We can link the Wikipedia article in the discourse thread, but IMAP and POP3 also have optional TLS. There's another port you can use for non-TLS, but these are the TLS ports. And if you have the your Let's Encrypt key files requested, they're present, they exist. If you have these keys, then you should be using these ports. Anyway, let's look a little further down. First one, I want to jump all the way to the bottom and just show you this SSL key path and SSL cert path. Environment variables specific to Docker Mailserver. This tells both Dovecot and Postfix, which are IMAP, POP3, and SMTP respectively, to use the certificate that I generated above. So they're both going to use exactly the same certificate. If you deploy these independently, either through MailCow containers or your own Postfix and Dovecot configuration, you'll probably need to get separate certs for each of those services, which can be annoying. So, just keep that in mind. Anyway, a few other important ones. These are specific to Docker Mailserver. This override host name, you want to give it a fully qualified domain name. My domain name that I have purchased from Squarespace is eom.dev, and Docker Mailserver wants a subdomain with that, so postfix.eom.dev is what I used. It's just, I name all of my services just exactly what they are. I could have gone for dovecot.eom.dev, and I think I also do, and I use that for IMAP because that's what it provides, so it doesn't really matter. You want to give it a fully qualified domain name. Postmaster address is just, an admin email address. Tell it to enable POP3. And then the last part is account provisioner. In my case, I'm using LDAP, and that's because I am hosting a separate LDAP server that this thing can connect to, and I can define all of my users, my groups, all of their additional information over on the LDAP server, and then the subsequent configuration here is just to tell it how to use that LDAP server. I would imagine that many people watching this don't have their own LDAP server, so you will need to choose a different account provisioner and configure Docker Mailserver or whatever service you use accordingly. But this one's working for me on, Open LDAP is the one that I'm using. Okay, so yeah, the next part is just deploying it and exposing it to the network as a service with all the ports, but that's just Kubernetes stuff, so this last one's not super important. Again, you can find this file on gitt.eom.dev, and there will be a direct link to it on the discourse post. So once this has been deployed into Kubernetes as is, there are a few steps that I need to do in order to get it actually working on the network. So as is, it will have SSL and it will be able to send messages locally, but it can't receive any messages from the outside world yet, only because I need to configure my router to port forward traffic to it. So again, I said at the beginning, you should be familiar with hosting your own website, so it's probably superfluous for me to explain port forwarding here, but I will be remiss if I do not do so, because there will be that one person who has made it this far and just doesn't know what port forwarding is. So what's happening here is I have one public IP address for my entire network. It points to the router that came from AT&T, and this is not that router. I switched out for a different router. It's neither here nor there. Point being, I log into the router's interface just on a web browser. Go to this firewall network address translation. Each router is going to have a different interface. Sorry, I'm getting off the point. Point is that my public IP address points to that router, and it's not over there, so I don't know why I'm pointing over there. But my public IP address points to my router, and my router is receiving traffic on all of these original ports. And what I need to do is tell the router, when you receive traffic from the outside world on port 80 or port 443, I want you to send it, well, assuming it is on either the TCP, UDP, or both protocols, I want you to send it to a local address, 192.168 something, on a given port. So I keep the original and the forward to port the same pretty much always, but you can make them arbitrary. I don't know why you would do that. That would be horrible. Anyway, so this is port forwarding. So, someone from the outside world wants to send me an email. It's going to come on port 25 to my public IP address, and that public IP address is port 25 on this router. And the router is going to say, I have received traffic on port 25. It is on either the TCP or UDP. It's going to be on TCP protocol. And so the local address on my local network is this 198.162, whatever. And so I want to forward whatever traffic I have received to this IP address on this port. And so this is how you get the service talking to the outside world. Again, I'm hoping that you are familiar with hosting websites, so you should have done this if you have hosted a website. And indeed, if you are using Certbot to get a third-party trusted authority key pair for your server, depending on the authentication method that you use, you probably will need to have port 80 forwarding to your local computer already. That is specifically for the HTTP challenge. This is a bit beyond the scope of the video, but when Let's Encrypt wants to issue you a certificate, they want to make sure that you actually own the domain name that you claim to own. So when you use Certbot, it is going to open up a web server on your local computer, listening on port 80, and then the official Let's Encrypt server is going to try and access it on the domain name that you have given them, and it should be able to, I don't know exactly what the key exchange they do is, but it's going to do some cryptography thing to confirm that the person requesting a certificate for this domain name actually owns the domain name for which they are requesting it. And that's done on port 80 for the HTTP rule. There's other ways of doing it that don't involve you using your local network, specifically DNS challenges. I can show you what that looks like in a little bit beyond the scope. So I needed to set up port forwarding for all of the ports I previously mentioned to go to whatever IP address the mail server ends up having. In my case, it's Kubernetes, so I use a load balancer service. It's issued an IP address from the load balancer, and that's the IP address I put here. If you're just running Docker locally, it'll just be the local IP address of your local computer, which is not the most secure thing to do. So anyway. Okay, so once you have done this, assuming that you have gotten your SSL certificate from a trusted third party, one that other people on the internet will recognize, You should be able to send emails locally within your local network. In my case, this 192.168.1 subdomain. I will be able to send to, any address on that domain on port 25 or whatever those ports are. It doesn't matter. And I should be able to receive from the outside world, because if Gmail tries to send me a message, it will come from some random IP address on the internet through port 25. My router here is going to say, port 25, I'm going to send you to 1.162 on port 25. And 1.162 is running my postfix server, so it's going to receive it. It's listening on port 25, and it does what it does with the email. So if you have set everything up like this, then that should work. You should be able to receive from any external email address. But you probably won't be able to send to any external email address. And that's because there's a lot of spam on SMTP. I've noticed recently that I'm getting a lot of scam text messages that come in the form of an email address. Again, it's beyond the scope of this video, but most cell phone providers, cellular network providers, offer a SMTP gateway address for your phone number. So, with like T-Mobile, for example, it's at tmomail.com or .net or something like that. And so you could put like your phone number at tmomail.net and send that as an email from your computer, and you'll receive it as a text message on your phone. And so a lot of scammers recently have been, I suppose, self-hosting their own email servers, which is why they don't like it. And they will use that to send to gateway addresses for phone numbers, and I've been receiving a lot of scam stuff on that sort of thing. I guess that like when I report the scam, it's reporting an email address, and they can just easily get another one. But anyway, neither here nor there. So yeah, long story short, internet service providers don't, or not even the internet service providers, so we're not there yet. The other email vendors, Gmail and Yahoo and iCloud, they don't really accept emails from just anyone. There are additional layers that we need to set up before they will consider it. This is, excuse me, my throat's getting a bit dry, but this is the email sender guidelines that Google offers. And, there's probably slight differences between one email vendor to the next, but on the whole, Google is a good guide for most things. So that's not exactly a good lesson to take in life, but don't take that. If that's your one takeaway from this video, then I have failed. But anyway, yes, here are the requirements for receiving emails from you. If you are hosting an email server, then you need to meet these requirements. Here are the requirements for all senders, and if you're sending a lot more messages, there are additional things you need to do. I'm not sending that many, at least just yet, so I just looked at these, and maybe we'll go into the more complex ones at a future time. And there's a lot of very fun things to look at here, aren't there? Look, isn't it great? Anyway, in short, the two things that I needed to set up in order to get Google to, accept my emails, at least so far, have been DKIM, DKIM, and where is it? A PTR record. And these are DNS records. So for this, I had to purchase a domain name. I own the domain name eom.dev. I owned that prior to starting this project, so I didn't purchase it just for this. And that domain name is provided to me. It was originally from Google, but they sold that to Squarespace, so it's Squarespace now. So what I needed to do was log into Squarespace, and I can't actually show you the page because it's there's sensitive information on the page, but I needed to log into my Squarespace account and go to a section called DNS records. And then I had to enter custom DNS records. Now, I already had to do this for, it's called an A record for IPv4 and a quadruple A record for IPv6 to get my discourse server running, or the original email server. When people type in eom.dev, that points to my home IP address, and I needed to add a custom DNS record to my domain name provider, specifying that. In addition to those two records, I needed to add a few extra ones specifically for email authentication. Let's see. This is a better explanation of them. This is an article from Cloudflare, and again, link will be on Discourse. So DKIM. DKIM is a cryptography thing. It's a public key cryptography, public key encryption. So the way this works is that you are going to add a DNS record to your DNS provider, your domain name provider, add a record of type DKIM, and the contents of this are going to be, well, if we go back to our Docker mail server and look for DKIM, we can see better examples. There are specific instructions of how to generate these keys here too. I'll go back and talk about those, but we don't need to look at that. I'm not seeing the example I was hoping to see. Anyway, sorry, did I just see it? DNS record, yeah, here we go. Yeah, anyway, so the DNS record is going to be of type DKIM, and it's going to contain a public key. So when you send an email from your server to, say, Gmail is going to do a couple of things. They're first going to look for this DKIM public key, and your Docker mail server or postfix instance, whatever it is going to have the private key existing locally. So when someone tries to send an email from your server, it is going to sign it, put a digital signature using the private key onto the headers of the email before sending it out to, say, Google. And then Google is going to receive the email, and it's going to use this DNS record to look up the public key and try and verify that this has come from the person that it says it has come from, my eom.dev email server. So I needed to add a DNS record with that DKIM public key, and it was quite simple to generate the keys. I just log into the Docker mail server. Unfortunately, I wasn't able to automate this through the Kubernetes setup, but that is why I had saved this extra mount path, this Docker mail server, temp Docker mail server, the thing I was calling the config personal or persistent volume claim. That one is where these DKIM keys get stored. So you run this command, setup config DKIM, that's it. And it's going to generate your keys. It will store them in that location I just mentioned. And then it will also have a text file containing the public key. You'll need to edit it a bit. I don't know where on this it showed how to edit it. Doesn't really matter. I'm sure you'll be able to find it. I just needed to remove a few quotes and new line characters. And then I just copy and pasted that public key into the DNS record on Squarespace. So Google is able to now verify that emails that are coming from an eom.dev address are actually coming from my specific server because it has been signed through a digital signature. But that's not all. We also needed this pointer record, this PTR. And these are kind of the reverse of the A record. So the A record works, someone types in eom.dev, it's going to return an IP address. And the PTR record basically is they say it right here, a reverse DNS lookup. So they're going to look up the IP address, and the PTR record needs to contain, in this case, it was postfix.eom.dev. So once we have done that, we should now be able to also send emails outside of the network. So, the base configuration with no SSL at all is able to, send to itself, send locally. We add SSL from a trusted third party to be able to receive emails from the outside world. And then we are going to add, at a bare minimum, DKIM and a pointer record in order to be able to send to the outside world. Now, there are additional things here. There's SPF, there is DMARC, and these are additional security protocols. And if you are, sending more than 5,000 messages per day, you probably need to, I think DMARC is required, and you probably will want to set up the other ones as well. I think other one, SPF. So, yeah, email servers are a bit complex. Unfortunately, if you go through all of this, it still might not work, which is the case for me. So a lot of internet service providers also are trying to cut down on spam coming from their networks. So by default, a lot of them are just blocking outbound traffic on port 25. So again, I've set all these things up, all of the SPF, or not SPF, I've set up DKIM, I've set up the pointers, the PTR, the PTR record. I have my port forwarding set up. My email server is running. I can receive from any external address. I have my SSL from a third party, but I am receiving timeouts when I am sending on port 25. Outbound traffic on port 25 to any address is timing out. I can use an external service. Let me see if I can, I'll just pull one up. This port checker. I believe this IP address is in fact one of those mail servers, and no, that's a web server. That's not what I want. I can quickly get one though. Here's an example email server that lives on the internet. This is a real one. We can see it has port 25 open, and every other port times out. But for me, on my local network, if I try to do netcat from my local PC, or if I'm trying to send emails using SMTP on port 25, the log messages indicate a timeout. So AT&T, my internet service provider, is blocking traffic on port 25. Frustrating. I went through a lot of effort to be blocked by AT&T. That being said, I have been reaching out to customer service, and they have the ability to manually override that and make it so I can send on port 25. It's just a matter of convincing them, and by convincing them, that probably means money. So we will see where that goes. I will post updates to that in the discourse thread. I think that's probably all that I want to say about self-hosting an email server. There are different use cases for why you might want to self-host an email server. In my case, I like having my own email is, eric@eom.dev. It's just my name and my domain. It's cool. But also, since I'm hosting a bunch of different services, it's pretty useful because they have a lot of built-in support, like GitT and Discourse have built-in features that you give them an SMTP address. I have, no, this is a bad example since it is postfix, but in their configurations, I will give them an email address and a password, and they will email me when it's time for them to update, or when things happen on the website that people are interested in, such as, if a pull request is opened on GitT, it will try to send emails. It's just not able to send them outside of the network just yet. So, working on that. If you have more luck with setting up an email server, if you actually get it to send outside of your network, I would really love to hear what internet service provider you have. That would be great. You can sign in with Google over on discourse.eom.dev. You can leave a reply there. Again, there will be a lot of supplementary materials and additional links here. And I think that's all I have to say for today. So thank you very much for joining me, and I will see you next time. Oh, wait a minute. I do have something else to say. Haha, gotcha. Something real quick. I am adjusting the way that I am doing this demo thread and my Git stuff. So I did this, actually, I flipped back and forth on this a bit. So this thread, these are just, progress updates on stuff that I'm building on the network. So I happen to be, working on deploying an email server this week. So that's why the demo is of an email server. I just kind of try to make it so it's, more palatable for a general audience as an educational thing. But it's also like just what I'm working on specifically for my network. And I post all of those updates in this thread one after another. The threads are organized in quarters by year. But at the beginning, I put these milestones here, and these milestones are like project names, like enable remote network access and public Luanti server, build a video summary bot, things like that. And those were referencing milestones on Git here. We can see them now. And we can see that I have changed those names to just be 2025 Q2. I'm finding that, here at the beginning, I set up a plan and I say, these are the things I'm going to work on. And then I'm immediately not interested in working on these things and I do other stuff instead. So instead of, trying to go against my own grain, I just am calling these milestones year, quarter, and I just stuff whatever I work on into them, and I will also do the same with this thread. So, whatever I happen to work on, I can just demo it at the allotted time. I will post it as a reply to this thread, and I can, keep these milestones up to date with what's actually happening rather than some idea that I had a month ago. So yeah, that's the update. And I think that will do it for today. Thank you very much for joining me, and I will see you next time. Toodaloo.